Hello, let's discuss about the video solutions of the test that we had given, and here is the first question. You can see that this is a pinhole camera, and in pinhole camera always a real image is formed, and real images are always inverted. So inverted with respect to the object. So let's understand this. Suppose here this is the butter paper, and on the butter paper the image itself is formed, right? And here is a very small pinhole, and suppose this is the object, right? And we can see that the light coming from here will reach here, and the light from this part will be reaching over here. So since the light is coming from the head of the object, so head is formed at the bottom and the tail is formed at the top. So this was the object and this is the image, right? So this is real and inverted image which we are talking about, correct? Okay, so here if I show you, if the image is like this, then the object has to be inverted, right? So the same the case over here also. So if this T is the image, right, or sorry, this, if this T is the object, this is the pinhole and the image should be formed over here, then this T should be appearing as on the screen as inverted one. So inverted T is this option, right? Okay, now in the second question we have the ray coming from air and it has to go inside the glass. So from rarer to denser it should bend towards the normal. So incident ray should go straight, but instead of going straight it is bending towards normal. So the C option is the correct answer. D option is only possible if the ray falls like this. So if the ray directly falls like this, perpendicular to the surface, then without refraction it will go straight. So C option is the correct answer, bending towards the normal. If you look at this question carefully, B is the angle of incidence and D would be the angle of refraction, because the angles are always made with respect to the ray and normal. Incident ray normal, so angle of incidence. Refracted ray and normal, so this is the angle of refraction. So here they are asking about the angle of refraction, and the angle of refraction would be D. So the correct answer is this. This question might be appearing quite confusing to most of us, right? Now these are called wave fronts, and wave fronts are always perpendicular to the ray, correct? So these are the rays, this is the ray which we were supposed to focus. So these are the rays. You can see that the ray is coming and going like this, so this is reflection. Here the ray is coming like this and from the surface it is bending towards the normal, so this is refraction. These two are the cases called diffraction. We may not understand this, but not at all an issue. What happens that the wavefront or the rays, they bend around the corners of the obstacle, that is called diffraction. So here we are only supposed to pay attention to the rays. So the rays are coming like this, rays are going like this, so this is reflection. Rays are coming like this and instead of going straight it is bending like this, so this is a denser medium, so this is the case of refraction. So our answer is D option. Okay, let's talk about the next numerical, that is light travels from medium A and the speed is this, and it goes into the medium this, and it goes to some medium B where the speed still decreases. So you are supposed to compare the refractive indices of the absolute refractive indices. So let's consider the two situations, and since they are talking about absolute refractive index, the upper medium has to be air, correct? Now the ray of light is coming from air, so 3 into 10 raised to 8. Now it is going inside medium A and the speed of the light is 2.5 into 10 raised to 8 meter per second. Here normal, bending towards normal, speed of light is 2 into 10 raised to 8 meter per second, right? And refractive index is represented by mu, for this is B. Refractive index of mu is the ratio of speed of light in medium 1 and 2. So this is 3 into 10 raised to 8 upon 2.5 into 10 raised to 8, and refractive index of B should be given as 3 into 10 raised to 8 upon 2 into 10 raised to 8. This will be equal to 1.5. Refractive index of B, 10 raised to 8 getting cancelled. Now 3 divided by 2.5, so 3 divided by 2.5, that is equal to 1.2. So this answer is 1.2. So we can say from here that the refractive index of B is larger than that of A. So which option? So what are they telling? The compare the absolute refractive index of A and and B is, so compared to A, B has got more refractive index, so our answer is greater. Let's move on to the next part of the question. If you remember guys, I had made a correction over here that this was actually 5.0 into 10 raised to 8 meter per second. So here the ray of light is going from air to benzene. So definitely benzene is a denser medium. You can look carefully that there is no refraction taking place. The light is going straight. So this medium is also benzene because the light is going straight, no refraction. So X is again benzene, right? So we may want to write down, this is a continuous medium, but when from denser medium a ray of light will come into the rarer medium. So when a ray of light comes out from the benzene to the air, it will bend away from the normal. So away from the normal means, which is the correct option? 1 is the correct option. And why 1 is the correct option? Because from here this ray is going straight, so 2 cannot be the option. Here incident ray and refracted ray are on the same side of the normal, so 4 cannot be an option. 3 is bending towards normal, so from denser to rarer it cannot bend towards normal. So this one is the answer to this question, so our answer is A over here. Now here what is happening here, this problem might be quite confusing to some of us, but not at all to worry about. The ray of light is coming from benzene to X, right? Now what is happening? Benzene is a denser medium, and denser compared to what? Denser compared to air. So speed of light in air is 3 into 10 raised to 8 meter per second, but when it comes into benzene, the speed of light will decrease. So that means this cannot be the option, because here the speed of light is increasing. This cannot be the option, speed of light is increasing. This cannot be option because the speed of light remains the same. So the only option left is B option. So the speed of light decreases when it comes from air to benzene. So this is the speed of light in benzene. Okay, fine. Let's move on. Now the ray of white light is refracted, and the greatest change in the direction is, so for that we might want to again go back to the dispersion topic, and we have already understood the dispersion through a prism. This is white light. White light splits up into 7 different colors. This is red, this is violet, again red, violet. If you extend them backwards, the angle of deviation for red light is less, angle of deviation for violet light is more. So which ray bends the most when it comes out? The answer is violet. So over here, greatest change in the direction means the angle of deviation, answer is violet. Refraction is caused by the change in wave's speed. When the speed of light changes, it bends, correct? So not at all to worry about all those things over here. Now this is a very interesting problem. What do we have over here is, we have a plane mirror. We have a plane mirror at the bottom, and this is a denser medium, or we can consider this as glass as well. This is air, right? So here in the question they are telling us the ray of light is going from air to glass to plane mirror. So air to glass to plane mirror. So what's going to happen is, a ray of light will come like this, Now since it goes inside a denser medium, it will bend towards normal. From here we can draw the normal. This is the angle of incidence. Here simple reflection is going to take place. So at the same angle like this, the ray is going to go bounce off at the same angle. These two angles are same. From here the ray is going away from the normal like this. So which is of our correct option? Let's match this one. Okay, we see A option is the correct answer. Let's look why these other options are wrong too. We can see that this ray is coming from here, from air. Now it is bending away from the normal. Instead of going straight, it is bending away. So this is not possible. Here the ray is almost going straight. So even though there is a change in the medium, the ray is going straight. Again a very bad option. It is the incorrect diagram. Here this part is correct. From here to here this part is correct. But we can see that the incident ray and refracted ray are on the same side of the normal, which is again not true, which makes this as our correct answer. Okay, let's look at this problem, question number 11. So question number 11, white light splits up into 7 different colors inside the glass. So white light splits up inside the glass and red comes at the top, violet comes at the bottom. So this is the correct answer. Here the emergent ray is moving away from the base of the prism, which makes this as an incorrect answer. Again over here violet is at the top, which makes this as the incorrect answer. Again over here refracted ray should be, emergent ray should be towards the base of the prism, incorrect answer. Right? Okay, let's look at this problem. Refractive index. So here if I ask you to draw a situation, this is the surface. Here is air, white is air on the top because it is absolute refractive index. So ray of light is coming from air, going to a denser medium. Why? Because refractive index of air is 1. Here this is 2.3. So this has to be the denser medium. So it will bend towards normal. Correct. So refractive index of a medium is equal to ratio of speed of light in the first medium. So that is 3 into 10 raised to 8. Here we don't know. So let's keep this as V. Now this is given as refractive index as 2.3. So simply V is equal to 3 into 10 raised to 8. This 2.3 will come down over here, meter per second. Right? Now let's calculate this. 3 divided by 2.3 is equal to 1.3. So our answer, this factor would be 1.3 into 10 raised to 8 meter per second. So which is our correct answer? B option. Okay, fine. Let's move on. And here this diagram is, we need not to even read the question, because we can see that from air to water, if this is the normal, incident ray and refracted ray are on the same side of the normal. Incorrect diagram. Here the refraction is going to take place, here reflection is taking place. This is not a mirror. Incorrect diagram. This seems to be reasonably correct, because instead of going straight, it will bend away from the normal. So this is the correct answer. Here again, instead of bending, going in the medium, this is simple reflection taking place. Incorrect answer. Looking at problem number 14, absolute refractive index is 1.1. So the same as this one. Now instead of 2.3, I need to divide this by how much? 1.1. So that means 3 into 10 raised to 8 divided by 1.1. Let's look at the answer. 3 divided by 1.1, that is 2.7 into 10 raised to 8. So this is our answer. Same as this question, guys. So 3 into 10 raised to 8. Now instead of 2.3, you are supposed to divide it by 1.1. Right? Okay. Now question number 15. So question number 15 is speed of light in plastic. And absolute means the upper medium is air. So ray of light is coming from air. 3 into 10 raised to 8 meter per second. Now this ray of light is going inside the plastic. So this is plastic. And the refractive index of plastic is 1.5, they have given. So we know that the refractive index of air is 1. So this makes the plastic as a denser medium, as it has greater refractive index. So it will bend towards normal. rarer to denser, bent towards normal. Suppose the speed is v. So refractive index of plastic is equal to ratio of speed of light in first medium divided by the speed of light in second medium, that is v. And what we are supposed to find out, okay, they have given the speed as 2 into 10 raised to 8. So instead of this one, I am going to use 2 into 10 raised to 8 meter per second. Cut, 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 cut. So here refractive index of plastic turns out to be 1.5. So correct answer is D. Now 16th one, ray of light traveling from air and its speed slows down to this one. So the speed was 3 into 10 raised to 8. Now here the speed is 1.71. So guys, I need not to do this entire calculation again. Instead of this 2 into 10 raised to 8, you are supposed to put 1.7 into 10 raised to 8. Let's calculate. 10 raised to 8, 10 raised to 8 cancels. So 3 divided by 1.71 and the answer is 1.75. So which makes this as the correct answer. Correct? Okay. A very good question. 17th one. Wavelength of a wave doubles as it travels from medium A to B. Now compared to medium A, the medium B has, right? So let's draw the situation to understand what is happening. This is A, this is B, this is the surface. So a ray of light travels from A into B. So ray of light goes from A. Now we don't know whether it is going to go towards normal or away from the normal. But we had already had a discussion that when speed increases, wavelength increases, and when speed decreases, wavelength decreases. So we can see that the wavelength doubles as it goes from A to B. So if this was the wavelength of light, suppose this wavelength is 1 centimeter. So here the wavelength becomes double, it becomes 2 centimeters. So what is happening? The wavelength is increasing, so that means the speed should have increased. So this is the medium with less speed, this is the medium with more speed. So this makes this as the rarer medium, this is the denser medium, so it should bend away from the normal. Hopefully guys you understood this. So what is happening? Since the wavelength becomes double, so the speed also should become double. So the correct answer is double the speed, twice the speed is the correct answer. Guys, frequency is something different. Frequency depends upon source of light, not the medium. When a ray of light goes from one medium to the another, the source of light from which the light is coming, the source remains the same. So the frequency will not change. Frequency will only change if there is a change of source, not the change in the medium. Okay, and let's look at this last one, right? We know that as the medium becomes more and more denser, the speed of light keeps on decreasing. So we know that, look at this one, last option. When refractive index increases, the speed of light decreases. Look at this one, this point. Very high, very low is the refractive index, very high is the speed of light, and when refractive index increases, the speed of light decreases. So this is the only correct graph. We know that when the absolute refractive index increases, the speed of light or the medium becomes denser and denser, speed of light decreases. Here what is being shown? Refractive index increases, speed of light remains constant. Not possible. Refractive index increases, so the medium becomes denser, so the speed has to decrease. Here the speed increases. Again a wrong option. Here again refractive index increases, speed increases in some different manner, but it is still incorrect. This is the correct answer, because as the refractive index increases, medium becomes denser and the speed of light decreases. Right? I'll be uploading the video solutions of the second part of the paper soon. Let's continue the second part of the paper, that was paper 2. And here in question number 1, you are being given a transverse wave and the particles we know that oscillate perpendicular to the direction of the wave. That means this is a transverse wave. These are called crests. These are called trough. Now when the wave is going like this, the particles, they oscillate up and down perpendicular to the direction of wave. And this one is a longitudinal wave. Here you can see that this part is called compression, this part is called rarefaction. So here when the wave is going in the forward direction, the particles, they oscillate like this. That means the particles, they will oscillate in the direction of the wave, correct? So this wave that is produced in string X is transverse wave and Y is longitudinal. So X is transverse and Y is longitudinal. C option is the correct answer. Let's look at the next problem. Here we have one of the effects of passing a ray of white light through a prism. So that is white light when splits up into 7 different colors. We know that this is red color and this is violet color. If we extend this forward, we get the angle of deviation less for the red light, angle of deviation is more for the violet light, and this effect, it is called dispersion of light. Right? Let's move on to the next problem. And here we have another situation of a plane mirror. So what happens in a plane mirror? This A option is the correct answer. So if this part, see, this part will not go on this side, but this part is going to remain over here only, and this part is also going to remain over here only, right? These all options are practically wrong. And when you stand in front of the mirror, our hand is, say for example this, then the image hand is again the same only, but from the opposite side. So A option is the correct answer. Now here in question number 4, that was a descriptive question, we can see that the ray of light is traveling from air, because the speed of light is given as 3 × 10⁸ meter per second. So here what do we have is, we have the air and the light is going in the glass. So what's going to happen over here is, the light ray is going from air to glass, and so it is bending towards the normal. But if you look carefully at this point, if we draw the normal, the angle of incidence is 0 degree. So when the angle of incidence is 0 degree, no bending takes place. It is because R is also 0 degree. So it is similar to this situation. This is the incident ray, this is the point of incidence, this is normal, and the ray of light goes like this only, because under this situation only the R would be 0. So the same case, I is 0, so R has to be 0. So if R is 0, no bending of light will take place, right? So speed of light between W and Q, that means in the air, is how much? 3 × 10⁸. Speed of light between Q and Y is, that means Q and Y is 2 × 10⁸. State the speed of light between Y and Z. Y and Z again means it is in air, and in air again the speed of light is 3 × 10⁸ meter per second. So the answer over here is 3 × 10⁸ meter per second. Write down an expression in terms of speed of light which may be used to find out refractive index. Refractive index is equal to the ratio of speed of light in air to that of the medium, so C by V, and here 3 × 10⁸ meter per second is in air, 2 × 10⁸ meter per second cancels off, and our answer is 1.5. This is also called absolute refractive index. So what I have done is, this is 3 × 10⁸ meter per second, this is 2 × 10⁸ meter per second in the glass. So wherever the incident ray is, that becomes medium number 1. This is the medium number 2, because there is refracted ray. So refractive index is speed of light in medium 1 upon speed of light in medium 2. So this divided by this, so that's why we have substituted this value, right? Okay, explain why there is no change in the direction. So I think I have made this part very clear, that here the angle of incidence is 0 degree, because the normal itself lies on the same incident ray. So what is going to happen is I0 R0. So if R is 0, so that means the refracted ray has to align itself with the normal. So R is also 0, right? So this reason is already explained to you. What happens to the wavelength of light as it passes out of the glass? We know that if speed increases, wavelength increases, and the vice versa. So what happened was the speed of light was less over here. When it came out, the speed increased from 2 to 3. Speed increased, so that means the wavelength of the light was less over here, and then the wavelength of the light increased over here. So what happens to the wavelength of light? The correct answer is wavelength increases, right? Moving on to the next part. The angle of incidence is the angle between the normal and the ray. So 2. So angle of incidence is 2. Now the angle of refraction is the angle between normal and the ray. So 4. So 2 and 4, that makes D the correct answer. Which of the following cannot pass through vacuum? Sound waves. All other waves are electromagnetic waves. All electromagnetic waves, they can pass through vacuum. Electromagnetic waves consist of visible as well as invisible light, right? Okay, whereas sound waves are not electromagnetic waves. Now here, this is a transverse wave, and we are being supposed to find out which is the wavelength. So wavelength means one wave. So you can see that from here, this is half wave, another half wave. So this makes this as a full wave. So the distance from the starting point to the finishing point of one wave, that is C, is the wavelength. Next was the question of glass slab. A very good question, and most of us, we get confused while doing these questions, right? See what happens is, let us analyze this situation. This is an incident ray, so it is bending towards normal. So up to here, not at all an issue. It continues to go in a straight line. From here it bends away from the normal. So this is correct diagram, right? Whereas over here it is bending towards normal. Till here it is good, but you can see that it is heavily bending away from the normal. We have studied that the angle of incidence and the angle of emergence are same. Here it is not being reflected. You can see that angle of incidence and emergence are different. What's the problem over here? Here it shows that the ray is going away from the normal while entering from air to glass. So this is practically wrong. Otherwise we might get confused in these two diagrams. But here what is happening? Instead of going straight, instead of bending towards normal, it is going away from the normal. This again last, you can see that there is no change in there is no bending shown over here, no refraction takes place. So this is again practically wrong, right? So this makes the first option as the correct answer. Moving on to the next question. Now, I think majority of us have done this question very correctly, right? And here you are being shown that this is the stone. So the ray of light from the stone cannot heavily bend like this. Here we can say that this is the angle of incidence, this is the angle of refraction, and it is bending away from the normal. Here it is supposed to go straight, because the angle of incidence is 0, so it should go straight. But even though the incident ray is perpendicular to the surface, it should go in a straight line, but instead they have shown bending. So A is wrong. B is correct. C, there is no refraction. You can see that it goes straight. Wrong. D, it is going from denser to rarer, so it should go away from the normal. Instead it is going towards the normal. Again wrong. Which makes B as the correct answer. Question number 10. A ray of light is coming from glass. So this is the point of incidence. Instead of going straight from glass to air, it should bend away from the normal. C is the correct answer. B is bending towards normal. Wrong. Refracted ray is on the same side of the normal. Wrong. D, it's a simple reflection, not possible. Possible under few cases. We are not supposed to worry about that. Okay, a very good question. V, I, B, G, Y, O, R, and after R comes infrared, IR rays. Here comes UV rays, and infrared rays are heat rays, and heat rays, they actually rise the temperature. So X is the position where infrared rays they fall, and infrared rays, they always increase the temperature. So the correct answer is infrared, right? Because VIBGYOR, infrared has got more wavelength compared to that of the red, so they are found somewhere over here. And ultraviolet has got less wavelength than the violet light, so they are found somewhere below, down over here. Okay guys, now most of us think that we have not studied this, so we cannot attempt this question. That's perfectly fine. We are supposed to understand what is this. This is called electromagnetic spectrum, EM spectrum. It's clearly written over here. Electromagnetic spectrum is a family of waves. That means it consists of starting, these are gamma rays. Gamma rays, they come out from radioactive substances. Gamma radiations are used to cure cancer cells. Then X-rays. Then we have UV rays. So between X-rays and visible, we have ultraviolet, right? We can also write down UV light over here. Then visible. So visible means it starts from violet, indigo, blue, green, orange, red, finally R. This is infrared, then microwaves, then finally over here you will get radio waves. These are all electromagnetic radiations. They all travel with the speed of light, that is 3 into 10 raised to 8 meter per second in air. They all travel with same speed. They all are light, but this is the visible light, the rest all of them are invisible light. Infrared rays are heat rays, they are used in physiotherapy. Microwaves are used for cooking. Radio waves, they are useful in communication. X-rays, we know doctors use it for, finding the cracks in the bones, right? UV rays are used to kill the germs, right? And also we have RO filter at our home that consists of UV to kill the bacteria and germs in the water. Now guys, these all are electromagnetic waves. That means they contain electric field vectors and perpendicular to that the magnetic field vectors as well. But this is out of our course, so just remember that they are called electromagnetic waves. They all travel with the speed 3 into 10 raised to 8 meter per second in air. Okay, now this electromagnetic spectrum, the gamma rays, they have very less wavelength. That means the wavelength itself is very, very small. But when you go from gamma rays towards the radio waves, the wavelength increases. So the radio waves, they have a very large wavelength. So going from gamma rays to the radio waves, the wavelength keeps on increasing. And we know that the 4000 angstrom is the wavelength of violet light and 8000 angstrom is the wavelength of red light. Okay, and the same question, if you might have paid attention over here, half of the answer was given here only. Gamma rays, X-rays, UV rays, visible rays. Then what do we have? We have infrared rays, then we have microwave rays. Like this, right? And since we have striked out this question, I suppose we should not go in much of the depth, but anyhow, if you remember this, it is more than enough for you, right? We have already discussed about this question. Describe a common use of X-ray. State radiation which has shortest wavelength. So the correct answer is gamma rays. Gamma rays, they have very short wavelength, and in going like this, the wavelength keeps on increasing, right? Okay, and let's discuss this because this is an easy question. Identify one feature that is same. So speed of light, they all travel with same speed, that is 3 into 10 raised to 8 meter per second in air. Correct? And fill in the blanks with by adding two names, right? So I think that we have already done this. State the radiation that is shortest, that is gamma. I think it is done. Question number 14, right? In question number 14, you are given, this is one wave, half, half. So this is one full, this is 1/4, 1/4. So 1/4 and 1/4 half and one full. So answer is 1.5 wavelength, or you can also write it down as 1.5 or 1.5 waves. Right? Okay. This was not a part of test, and eventually actually I forgot to give you these two questions. If you look at these four diagrams, which of the diagrams is correct? Of course this is wrong, because white light splits up into 7 different colors in the glass itself, which is not shown over here. White light remains white and then it splits afterwards, which is wrong. This is the correct answer, white light being split up into 7 colors, and finally the rays are towards the base of the prism, emergent one. Here the emergent rays are coming from in the base, and here no splitting, wrong diagram. This is again a wrong diagram. The emergent ray should come like this. Okay. Last one. A ray of light passes through one of the surfaces of glass prism and like this, and you are supposed to find out the angle of incidence over here. Since this angle is 90 degrees, so if I draw a normal, the normal falls on the incident ray, so the angle of incidence is 0 degree. So the angle of refraction is 0 degree, no refraction takes place. This is 90 degree, vertically opposite angle 90 degree. If this is 45, then this has to be 45 degree, because 45, 45, 90 makes the 180 degree. So this is the point of incidence, this is the normal, this angle is also 45 degree, because this whole angle is 90, out of that this is 45. So this was the question, that what is the angle of incidence when the light strikes over here, right? So the correct answer is 45 degree. Okay.